Hi, my name is Muhammad Naiman bin Muhammad Noaidi, 180022372 from Petroleum Geoscience. And today I'll be explaining about the analysis from the calculation on question 1A, and then we'll be moving on to the data interpretation issues that can be encountered by geoscientists while they while they are doing the seismic interpretation or any kind of interpretation. Based on the calculations of question 1A, we can see that well B has the lowest probability matrix amongst well A and well C, while well C has the highest probability matrix than well A and well B. And in figure 1b, we can see the location of the three wells, with well A and well B at the bottom and well C at the very top. From the calculation and the seismic data given in the question, we can see that well C has the highest probability than well A and B, whereas well A has the lowest probability than well B and well C. The higher the probability in a well, the higher the potential of a reservoir containing oil or hydrocarbon. C is the new well location in the PM307 field of the Malay Basin. There are many data interpretation methods that can be used to enhance the image and improve the data interpretation made by the geoscientists. One of these methods is the multiple. What is a multiple? Multiple is a type of energy which has more than one reflection in its travel path. It may disguise, hide, or falsely assume to be primaries, which cause data analysis and processing images to be more difficult to interpret. The primary wavelet may be affected, and distortion in quality of imaging and obstruct primary reflections. A wide range of techniques have been derived and applied to solve this issue. Overall, these techniques differ based on the type of multiples, which are long period and short period. Predictive deconvolution, surface-related multiple elimination, and shallow water demultiple or SWD focuses on short-period multiples, whereas high-resolution linear and parabolic random demultiple is for long-period multiples. Demultiples techniques mentioned before are generally time-consuming, expensive, while accurately removing the multiples masking the important events. The next method is deghosting. In marine seismic, there is always an unavoidable ghost effect from the result of reflections of waves of the sea surface. The energy from a marine source emanates in all directions, such as downwards into secondary signal. These ghost reflections can either be source ghost, receiver ghost, or both, where all three of reflections meet the sea surface before being recorded at the geophone. They pose a threat because of their constructive or destructive interference on primary reflections and in some cases mistaken as primaries. The process of source and receiver deghosting upgrades the conventional data to the appearance of a broadband data. This broadens the bandwidth and improves visibility of impedance contrast for enhanced imaging. There are two possible approaches to deghosting in processing. First, a statistical approach based on the classical minimum phase deconvolution algorithm, and second, a deterministic approach which entails computation of the analytic inverse of the ghost operator. While statistical deconvolution has remained the workhorse in wavelet processing of land data, It has been skewed in modern marine processing flows in favor of deterministic techniques. In conclusion, well C is chosen as a new well location in PM307 field in the Malay Basin. Well C has the highest probability matrix than well A and well B. The higher the probability in a well, the higher the potential of a reservoir containing hydrocarbon. There are two types of data interpretation method, D-multiples and D-ghosting.